Greetings, Professor and teaching assistants. Our group, made of Ignacio Aguilera, Jesulín Domínguez, Mikaela Maldonado, and myself, Nicolás Jiménez, will speak about the modifications made to a base 4D model of a construction project, the structural work of it, and the control of the activities involved. First, we'll talk about the 4D model itself, made in Navisworks Manage.
Well, with Timeliner, a tool used to gradually plan the actions of a project, we begin by setting the start date and then establish an end date within a speculative framework. As unforeseen event may arise during construction. The categories used for the simulation correspond the route construction phase, covering from the basement to the sixth floor. How can we see on this stage? Okay. The simulation starts with the footings where the rebar is placed first, followed by the formwork to shape the structure, and finally the concrete pouring to ensure optimal execution. This sequence is applied similarly to the footings, elevations, slabs, with specific colors assigned to each stage, ensuring that the formwork removal is the last action. The dates, the dates on this stage reflect the typical timeline of a construction project. Rebar installation takes 4 days, depending on the section formwork follows with a similar duration. Concrete pouring lasts 7 days, considering the amount of material needed as well as the time required to start working on this next elevation. And the average of duration between each floor is about maybe mm, 1 month, 1/2 month. Once the dates are assigned with use task types, how can I see on this column? Column we use task type categories and links to identify the phase of the process and the structure being worked on. In the configuration, the following colors are used, for example, with light blue for rebar, red for formworks, orange for installation, green for concrete pouring, and yellow for formwork removal. Now with this channel we will can see the simulation of this project. Okay, that's how it have to that's how has to be.
A problem that surged was the fact that the forward removal, indicated in yellow, doesn't appear in all of the building at the end, even if we configure the order of the process properly. The visual error is due to an incorrect configuration in the timeliner, specifically in the finish appearance parameter of the task predicting the one you want to visualize. The fundamental problem is color overlap in the 3D model. Complete construction activities such as work placement red and concreting green are configured so that their elements retain their face color upon task completion, instead of reverting to a neutral state or the model's original color. This color persist creates a direction conflict. When the simulation progresses to the formwork removal task, the yellow color assigned to this activity fails to be applied effectively because the structural elements are still visually blocked by the red and green color layers of the immediately preceding task. This distorts the workflow, presenting as the correct display of yellow for formwork removal is the overridden by the color retention setting of the already complete phase. The solution involves ensuring that the end appearance and the task configuration is set to none or the appearance of the base model.
Now, here's the planning analysis carried out for the project, applying the last planning system approach. The intermediate plan for the 4 week window starting at week 15 is structured around maintaining continuous production by anticipating and resolving constraints before each task enters the weekly plan. In this period, the emphasis is placed on evaluating what conditions must be met for the structure cycle to advance without interruptions. The main constraints affecting the workflow relate to availability of materials, timing of inspection, access to work zones, coordination between trades, and readiness of equipment and crews. Each constraint must be explicitly identified and linked to a concrete make-ready action to ensure the work is thoroughly executable when structured.
Material-related restrictions include ensuring steel reinforcement, formwork components, and embedded installation elements arrive on time and in the correct quantities. Delay in these items tend to create immediate bottlenecks, so part of the planning effort focuses on validating purchasing orders, confirming delivery dates, and maintaining small on-site buffers for critical components. Inspection-based restrictions include many structural tasks that depend on timely review by supervisors or external inspectors. These are managed by pre-scheduling inspections, streamlining approval routes, and preparing documentation in advance to avoid last-minute observations. Another important category, workspace and access constraints, are, for example, work areas must remain clear, safe, and properly coordinated so that trades do not interfere with one another. This requires confirming scaffold availability, ensuring safe access routes, and verifying the previous tasks have fully finished before the next crew enters the area. Coordination-related restrictions arise particularly in installations that must be embedded within structural elements. To avoid rework or stoppages, layout teams must finalize routes and specialty constructors must confirm compatibility before reinforcement and formworks are closed. For week 16, the short-term plan focuses on verifying that all constraints associated with the current stage are released. The primary commitments include completing the active formwork phase and performing all preparatory actions required for the upcoming concrete pour. Alongside this, the team must resolve pending restrictions linked to reinforcement and installations planned for the following week. Success during this week depends on the team's ability to clear these constraints early, confirming material arrival, finalizing layout checks, securing inspection time slots, and validating equipment readiness. The project's performance shows a downward trend in the reliability of the plan over the weeks, with an SPI that starts above the expected value of 1, but then falls progressively to values between 0.82 and 0.86 in the final weeks. This indicates that production started at a slightly higher rate than planned but subsequently slowed down, accumulating delays. The PPC follows a similar pattern from very high levels up to 100% in the first weeks, but then it falls steadily to values as low as 45% towards the middle and end of the period analyzed, reflecting a significant reduction in the weekly reliability of scheduled ability completion. Taken together, these indicators show that the workflow lost stability as the project progressed, suggesting increasing difficulties in the preparation of activities and coordination between teams. For its part, the PCR shows considerable variability, despite reaching high values in certain weeks like 95%, 96, It also falls sharply in others to levels of 45–50%, indicating that the release of restrictions was not consistent over time. This inconsistency is directly reflected in the reported CNC, where the factors that most affect execution are recurrent: lack of experienced labor, lack of space, lack of materials, poor performance estimates, as well as specific cases of administrative problems and project changes. The prevalence of these constraints show that the make-ready process needs to be strengthened, particularly in terms of resource planning, availability of workspaces, and supply coordination. Improving these aspects would increase the proportion of constraints removed and consequently raise the reliability of the weekly plan, avoiding drops such as those observed in the PVC and SPI during the second half of the period. That concludes our presentation for track 7. Thank you for watching.